In this lesson, we'll be talking about linear equations in one variable. So, first off, an equation is simply a statement, such as the one below, that two expressions, such as these two, are equal to each other. And so a linear equation is one that, if you can manipulate it, you can end up with something of the form ax plus b equals 0. Let's see if we can find something on this equation that might be a linear equation. What I'm going to do first is distribute my 5 to both terms, and then distribute my 3 to both terms, and I still have a 5x over here. So combining like terms, I end up with 10x minus 5 equals 3 plus 2x. And then let's subtract 2x from both sides, and at the same time I'll go ahead and add 5 to both sides. In doing so, I end up with 8x equals 8. I divide by 8, and I get x equals 1. This is what we call a conditional equation. Conditional simply meaning that it has one solution, or in a more general case it might have more than one solution, although this does not occur for linear equations. It's only satisfied on one condition, namely, x has to be 1. Next example. For this one, we have some denominators that are numbers. And it would be nice to fix this. So what I'm going to do is I'm actually going to multiply both sides by the least common multiple of my 3 denominators. So if you look at these values, you say, what's the least common multiple of 2, 4, and 4? It's actually going to be 4. That I'm going to multiply both sides by. And when I do that, again, distribute the 4. So in the first term, I still have a 4x minus 3. But what happens is I have times 4 but divided by 2. I think of that as 4 over 2, and I get 2. Now when I distribute the 4 to the 7 over 4, the 4 cancels with the 4 underneath the 7 and just leaves me with a 7. Similarly, the 4 cancels with the 4 below here, and I get 8x plus 1. Let's finish this in a similar fashion. I get 8x minus 6 plus 7 is equal to 8x plus 1. And then if I combine like terms, I get 8x plus 1 on both sides. Now that is a little bit strange. 8x plus 1 on both sides. What I usually do when I see this is I go ahead and subtract off the variable. That way I'm left with a very obviously true or false statement. I get 1 equals 1. That is obviously true. So, I'm going to say anytime that I have an obviously true statement, that it didn't matter what value of x that I used. This actually has all real numbers as the solution. You might also know the symbol for real numbers that I mentioned before is this R symbol. And by the way, we call this type of equation an identity. Identity equations have all real numbers as their solution because the left side is actually the same as the right side, regardless of what value of x you put in. For the next one, let's start out by distributing the 4. I get 4x plus 9 equals 4x plus 16 minus 10. Combine like terms and I get 4x plus 9 equals 4x plus 6. This one is again looking a little bit strange. I will subtract the 4x out, and I get 9 equals 6. That is obviously a false statement. So whenever I arrive at an obviously false statement, I don't have a solution. There's no value of x that's going to make this true, so I actually say no solution. And I can also use the empty set to represent no solution. We call these types of equations contradictions. Contradictions saying that this equation cannot happen. if I were to try to put in a value of x on the left, it would contradict the value I get on the right. It's impossible to find any value of x that solves this equation. Let's do another one. So if I distribute my 4, I get 4x plus 8 minus 12. And then I distribute my 5, and I get 5x minus 30. 4x minus 4 equals 5x minus 30. Let me subtract 4x from both sides. And while I'm at it, I'll go ahead and add 30 to both sides. So I get 26 is equal to x, and that's my final answer. This was another example of a conditional equation. Let's do another one. Now, this one is actually what we might call a rational equation, but it follows similar steps to what I did just a moment ago when I had other denominators. I'm just going to multiply by whatever I can to get the denominators out, the least common multiple, if you will. And while we'll do more examples of these in the future with these larger denominators that have variables in them, I'm just going to multiply both sides by x minus 4. So when I do that, on the left side, I just have 3x. On the right side, I do need to distribute the x minus 4 to both terms. So I get 5 times x minus 4 plus, and then in the second term, the x minus 4's cancel and just leave me with a 12. Let's continue distributing. 3x equals 5x minus 20 plus 12. So 3x equals 5x minus 8. We subtract 5x from both sides, and I get negative 2x equals negative 8. So divide both sides by negative 2, and I get x equals 4. So this is again what we would call a conditional equation.